So for this third video, to talk about the basics of learning trigonometry with the unit circle, we're going to focus one last time on the first quadrant of the unit circle. And from there, we're going to actually expand to finding the degrees, the radians, and the coordinates of all the special places in the unit circle for 30 degrees, 45 degrees, 60 degrees, 90 degrees, and all of those ways around the circle. So first of all, let's remind ourselves here, what are the special degrees and radians that we need to know in the first quadrant? Well, that would be 0 radians and 0 degrees. Then we go to 30 degrees, and it's somehow easier to think of these degrees first. And then we go to 45 degrees, and then 60 degrees, and then 90 degrees. We don't care about 15 degrees or 75 degrees. Well, that is until we get to maybe the half angle and double angle formulas. We do care about these degrees in the first quadrant, because these will give us all the remaining special relationships for the rest of the 4 quadrants of the unit circle. Now let's talk about radians. This is 0 radians at 0 degrees. At 30 degrees, it's pi over 6. At 45 degrees, it's pi over 4. At 60 degrees, it's pi over 3. And at 90 degrees, pi over 2, as illustrated in the previous videos. Now the next thing I would do in filling out this chart is put your XY relationships. Sine is the relationship to y on the unit circle, and cosine would be x. This is where I like to say sine and cosix, maybe to try to help yourself remember these. Tangent is y over x, and if you need a way to remember that, it's like slope, rise over run, though that's just a way to remember this. The cotangent is the reciprocal of tangent, so it's just the reciprocal of that. And then for cosecant, it's the reciprocal of sine, or 1 over y. And secant would be 1 over x, the reciprocal of cosine. Now, the memorizing technique that I showed you in the previous video is to start off with 0, and then go up by ones. 1, 2, 3, and the denominators are always going to be 2 in each of these cases, and the numerators are always going to be square rooted. Now, I'm not going to write the square root of 1 because the square root of 1 is 1, and this is my answer for 90 degrees. Now, as this is true going down the column, we can go up the column, starting with 0, just like we started up here with 0. And as we went down this column, 0, 1, 2, 3, 1, with the denominators of 2 and the numerators square rooting, we will do the same thing here. So this is square root of 2 over 2, this is square root of 3 over 2, and this here is 1. So as you see as I go down this column, mirrors it perfectly this way. This is so if you have to create this table quickly on any test that does not have a calculator requirement or any notes, this is a quick way to do it. Now for tangent, it's going to be y over x, and 1 divided by 0, or sorry, 0 divided by 1 is 0, and 1 divided by 0 is undefined. I'll abbreviate it with UND. Now this is going to be square root of 3 over 3, this is going to be 1, and this is going to be square root of 3. Now these were all derived in the previous video. Now, if I've memorized this second column, I can then inverse it for this column over here by putting this as a 0, square root of 3 over 3, 1, square root of 3, and undefined. So again, if I've memorized the sine column, I can get the cosine column. If I've memorized the tangent column, I can get the cotangent column. And cosecant is taking the y and flipping it on its head, so this would be undefined, because 0 over 1 flipped on its head would be 1 over 0. This is going to be 2, because that's the flip of 1/2. This is going to be the square root of 2, and this is going to be 2 square roots of 3 over 3. Now again, these were derived in a previous video. And this is just 1, because the reciprocal of 1 is just 1. And then once we know the cosecant column, we can then follow it backwards and get the secant column by starting with the bottom, which is the same as the top, then 2, then square root of 2, then 2 square root of 3 over 3, and then finally the answer up here is 1, because that's a reciprocal of 1. So, in 5 minutes, I've given you the quick lowdown of how to make this chart really quickly, and now we're going to fill this out to all aspects of the unit circle. Okay, so we're going to start here at 0 degrees and 0 radians with the point 1, 0. This at 0 degrees and 0 radians, or 360 degrees and 2 pi radians, is going to be the start and the end of our unit circle. Up here at the top, this is going to be the coordinate 0, 1, otherwise known as the y-intercept at this position here. If the line was crossing at this point, it would be 0, 1. And this is going to be 90 degrees, and it's also going to be pi over 2 radians. Over here at the 180 degree mark, we're going to have the point -1, 0, because with a radius of 1, as explained in the earlier videos, this is going to give us a -1 on the x and a 0 on the y, which gives us 180 degrees. Oops, it looks like I wrote off the edge of my paper, which I cannot do since I'm using Microsoft Pen. Alright, so 180 degrees and also 2 pi, just pi radians for that spot. Got it. Now, down here at the bottom, this is going to be another 90 degrees, or 270 degrees, which is going to be another pi over 2. So this is 1 pi over 2, 2 pi over 2, this is 3 pi over 2, and this is the coordinate point of 0, -1. Now, we go 4 pi over 2 here, and this takes us to 2 pi, which also takes us back to 0 degrees, so I don't feel like writing that over again. But please note that we're not going to include the values of 2 pi and 360 degrees, because that would just be equal to 0. Okay, so where are we going to go now? Well, we're going to start off with our 45 degree angles. Those are definitely the next easiest ones to do. So 45 degrees here, which is going to be pi over 4, and this, according to our chart, is going to be square root of 2 over 2 and square root of 2 over 2. And these were derived in a previous video, but now we're putting them on this piece of paper. Now you're probably wondering, what's the importance of this? Well, we are going to be coming back to this a lot in the first and second unit. You will see many times in the notes that I've written where it says, please go back to the unit circle that you made in the first session videos. And this is the one I'm talking about, because a lot of these are going to be very important and referenced quite a bit. But we need to go to the second quadrant. So this is 45 degrees, this is 90 degrees, and you can see that I went 3 slices on this pizza here to get to 45 degrees, so I'll go another 3 to get to 90, and another 3 to get to another 45 degrees from 90, which is 135 degrees. This is pi over 4, 2 pi over 4, reducible down to pi over 2, and this is 3 pi over 4. Come on, buddy. There we go. 3 pi over 4. Now, the coordinate point over there is the same. Notice how they're mirrored? It's going to be the same over here, square root of 2 over 2 and square root of 2 over 2, but I'm in the second quadrant, or my x values are negative. So I've just taken this point and mirror imaged it over the y-axis to this point right here. So this is 135 degrees, add another 3 wedges to get us to 180, or 4 pi over 4, and then I'll go another 3 wedges to get another 45 degrees from 180, which adds up to 225 degrees. And in terms of radians, this was 1 pi over 4 at 45, we'll count by 2 pi over 4, 3 pi over 4, 4 pi over 4, and then this one would be 5 pi over 4. Now, a lot of people start to get confused when we have improper fractions here, but we have to get to 2 pi all the way over here, which is going to be 8 pi over 4, and you can see that we'll actually land there. Now, this location can be copied from this location up here in terms of its x and y coordinates, because the distance between here and here, y and x distance from the origin, is the same as it was at 135 degrees, except that we're in the third quadrant. So now my positioning is going to be negative square root of 2 over 2 and negative square over 2 over 2 for x and y. So let's finish up my pi over 4s. So we got 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4. Then this one over here is 7 pi over 4, or 45 degrees added on to 270 degrees, which is 315 degrees. And then I can put that square root of 2 over 2 and square root of 2 over 2. Now, do you know which one's negative? It's the y one in this case, because we're in the fourth quadrant, where my y value is negative and my x value is positive. Now, if I continue going by pi over 4s, this would be 8 pi over 4, which is 2 pi, which again gets us to the end of our unit circle. Well, let's change colors a little bit and do, let's do pi over 6. Pi over 6, which is also known as 30 degrees. Now that's 2 wedges of our little pizza slice here. And this is the coordinate point of square root of 3 over 2, comma 1/2. Now, I see a lot of students make silly mistakes copying this from the table and getting these backwards. But what I need you to do is I need you to take a look at this triangle here. Now, I'm going to try to draw my line as straight as possible, but freehanding this on a tablet is a little tough for me. So here's the triangle in blue, as I created here. And you can see that my x distance is definitely more than halfway to this unit value of 1, where my y distance, if I eyeballed it, would be about halfway up the y line. So that's where I get my 1/2 and square root of 3 over 2. If you check this point, then you will do just fine. Because if you get this right, then you can copy these to all the proper spaces. In fact, I can copy it all the way over to this spot over here, which is going to be at this location. And this location is going to be our negative square root of 3 over 2, comma 1/2. I can take everything from the right side of this unit circle and copy it to the left side, keeping in mind what quadrant I'm in. Think of a butterfly folding its wings along the y-axis. Now, getting to this degree measurement can be pretty easy. You can see that this is 15 degrees away from 45, so this would be 15 degrees away from 135, so this is 150 degrees. So you can kind of do some deduction here and realize that every single pizza wedge is 15 degrees on this unit circle, and therefore you can see that 2 pizza wedges away from 180 is 150. Good way to check your answer. Okay, now I'm going to hold off on doing radians though. I feel that radians are kind of nice to do at the very end, and we'll cover those. So I'm not going to forget the radians, and please try not to forget yours while creating your own unit circle. But now what I'd like to do is I'd like to find where this point is in the third quadrant. So you'll notice that I just copied it from the 30 degrees to the 150 degrees. Well, shoot, I can just kind of copy it down here to this location, imagining folding the piece of paper over the x-axis. You'll notice that it's 2 wedges away, so 2 wedges away here, or 1 wedge away from 225, gets us this measurement here at negative square root of 3 over 2, comma negative 1/2. All right, it's looking pretty good here at 210 degrees, and I could pick 210 because it was 15 away or 30 away from the 180. Now I go straight across to my fourth quadrant, and I copy that point, which is going to be positive square root of 3 over 2, comma negative 1/2 here, since I am in the fourth quadrant. And if I'm 15 degrees away, then this is going to be 330 degrees. All right. So now I've got all those angle measurements done, so now it's time for me to bust out another color. Let me bust out the color red here and do the 60 degree angle, which happens to be pi over 3, which is going to be the flip of this, which is now 1/2 for my x and square root of 3 over 2 for my y. Again, if you see the red line getting dropped straight down, it's about halfway along the x, so that 1/2 seems right. Again, if you can get the blue right, you're going to get the red right, because you're just going to flip those two. Now let's put this in its correct place, 15 away from here, which is 120 degrees. And that 120 degrees is going to be the copy of that point, which is negative 1/2, comma, square root of 3 over 2. And then we'll go down here, because that 120 degrees, we'll just drop that all the way down to this spot, 15 degrees away, which is 240 degrees, which is going to be both negative 1/2 and negative square root of 3 over 2. And then we're going to go to this location down here, which is 30 degrees away from 270 degrees, which is 300 degrees, which gives us positive 1/2 and negative square root of 3 over 2, thanks to being in the fourth quadrant. All right, so how do we take care of our radians? Because you'll notice I skipped the radians for most of the red and most of the green. I want to focus just on the red ones. Let's just focus on that because this is pi over 3. So the next 60 degrees would take us 1, 2, 3, 4 wedges to this one over here. So if this is pi over 3, then this is going to be 2 pi over 3. Oh, 2 pi over 3. Microsoft Word doing a little funky stuff. Now, if we go another 4 wedges, it takes this one here, which is 3 pi over 3, which reduces to pi. And then another 3 wedges here takes us to, or 4 wedges takes us to 4 pi over 3. And again, another improper fraction. Another 3 wedges here takes us to, another 4 wedges here. So if I go from here, 1, 2, 3, 4, this takes us to 5 pi over 3. And another 4 wedges is over here. Wedges over here takes us to 6 pi over 3, and 6 pi over 3 is 2 pi. Now, the hardest ones to do is going around the unit circle by, let's go with the blue pen here. And the blue pen was pi over 6. So counting by pi's over 6s it's the most time consuming because you're going to see a lot of overlap. Every 2 wedges is a pi over 6. So 1 pi over 6, 2 pi over 6 takes us to 60. And we've already done 2 pi over 6, which is pi over 3. Then 3 pi over 6, which is pi over 2. Then 4 pi over 6, which is 2 pi over 3. And this brings us here, which is 5 pi, come on Microsoft, 5 pi over 6. Okay. Another 2 wedges takes us to 6 pi over 6, which is pi. Another 2 wedges takes us to, come on, 7 pi over 6. All right, another 2 wedges takes us to 8 pi over 6, which is 4 pi over 3. Then 9 pi over 6, another 2 wedges, pi over 3, 3 pi over 2. And then 10 pi over 6, which reduces to 5 pi over 3. And this takes us finally to this spot here, which is going to be 11 pi over 6 at that location right there. And that, of course, sets up our final 2 wedges, which takes us to 12 pi over 6, which is, and I better just put it here because I've been saying it all day, but I just haven't been writing it. This is going to be 2, whoops, come on. Change to the good color black here. 2 pi. That's right, 2 pi. We are at 2 pi when we get back to 360 degrees. So now that you've built this and you've made all of your beautiful, pretty points, you may want to just put some big points here at each of these locations, and you can see Microsoft just can't handle all the awesome art that I'm doing. But if you just focus on these points here, as I slowly break this document, these points are really the key to you solving the rest of the things in this unit and beyond, as we constantly refer back to this work that you've done on the unit circle in this first session of videos. Thank you for watching.